Hello everyone, and welcome to a Matt's Mysteries bonus episode. Imagine for a moment that there is indeed a multiverse, with each universe, including our own, being represented as a bubble sitting comfortably at the bottom of a pot of boiling water. Our universe is formed, eventually rises to the top of the water, and then it's gone at a seemingly random time and without warning. Now, you're probably asking yourself, Matt, what does this have to do with today's topic? And why are you making pasta with our universe? And while I don't have an answer for that second point, the answer to that first question is you got a small taste of existential dread with the last bonus episode, and I wanted to ruin your day by giving you another bonus episode full of, you guessed it, more existential dread. You're welcome. Anyway, while false vacuum decay is theoretical in nature, should it occur, an outward expansion at the speed of light from a single point would fundamentally alter everything within our universe that it collides with. And yes, that includes you, me, and that sandwich over there. Will we be wiped out in this scenario? Maybe? With that said, one thing is certain, the universe as we know it, and everything in it, will cease to exist. This, like the last bonus episode, is a science, space-based pseudo-mystery. So, put on your favorite scientist hat and buckle up, because I'm Matt, and this is Matt's Mysteries. Imagine, if you will, the endless void of space, a cold, dark, and seemingly infinite expanse stretching beyond comprehension. That's terrifying on its own. Now, picture the entire universe. Our home, everything we know, collapsing into a fiery, chaotic oblivion. Sounds like a nightmare, doesn't it? I hate to say it, this is no mere fiction. This is a terrifying, scientific possibility. One of many that has been proposed over the years to explain how everything could meet its end. And before we dive into the main event, let's take a moment to consider some of the other potential doomsday events that we've dreamt up. Each of these could warrant a whole story on its own, but for now, we'll keep it brief and relatively haunting. Once again, you're welcome. First, there's the Big Rip, a catastrophic unraveling of space-time itself. Picture this. As the universe expands, the forces tearing it apart grow even stronger. Eventually, galaxies, stars, planets, and even atoms would be torn apart, ripped away by the fabric of space itself. Think of it as a slow, particularly horrifying disintegration. Next, there's heat death, a hilariously chilling, inevitable scenario where the universe stretches out into a cold, lifeless void. As it continues expanding, stars burn out, and matter is so spread out that it can no longer interact. The universe, in essence, will die of cold, with entropy claiming every last scrap of order. Finally, we have the Big Crunch, the ominous mirror image of the Big Bang. Once again, picture the universe. After billions of years of expansion, it reverses course. Gravity eventually overwhelms everything, pulling it all back in. Galaxies, stars, planets, you name it, all of it collapsing together into a singularity, where everything that once existed would be crushed into an infinitely small point, a crushing return to the darkness from which everything began. Are you scared yet? What do you mean no? Well, alright then. Let me tell you about something far worse than literally all of those things. Something that haunts my very thoughts. A scenario that is sure to send a chill up your very spine. even though we might not know what's happening until it's kind of too late. It's called false vacuum decay, and it's, without question, the most terrifying of all of the end of the world scenarios. To properly understand false vacuum decay, let's first do a quick lesson on the Higgs field that permeates the universe. You see, the Higgs field varies in strength based on its potential. A nice visual to help paint this picture is to imagine a ball rolling along a track. The higher the ball is on the track, the more energy it has. This Higgs potential determines whether the universe is in a true vacuum or a false vacuum. Like the first question at the beginning of this video, your next question is probably something along the lines of, what are these states exactly, and why are you vacuuming? And like earlier, I can't answer the second question, but to answer the first, and to paint a picture of both states, let's use a slightly different visual, this time with a valley as the setting. A true vacuum is stable, the lowest possible energy state. In our little valley example, a true vacuum can be visualized as a person sitting still on the ground level of the valley's middle. Now, a false vacuum, on the other hand, is considered metastable, since it's not exactly stable, but isn't decaying either. Once again, looking at our valley example, this can be represented by you sitting in a divot on the wall of the valley. You're not actively rolling down the valley wall, but a little push could send you tumbling. So, why does any of this matter? Well, a metastable universe poses two problems. The first is that, in theory, if you were to create something that emits enough energy, you could push a portion of the universe into a true vacuum. This would create a bubble of sorts, containing the true vacuum, that would expand in all directions at the speed of light. The second is that according to quantum mechanics, in theory, a particle can tunnel through the barrier separating one region for another. This would also apply to the vacuum state, meaning that a random quantum fluctuation could yield a particle that is suddenly in the true vacuum. In short, by pushing something over the threshold into the territory of a true vacuum, you're pretty much dooming the entire universe to some sort of apocalyptic fate, with absolutely no means of stopping or escaping it. This whole theory, and the greater mystery surrounding it, is something that has become relatively popular, considering that measurements of the Higgs boson seem to point to the fact that our universe is metastable, meaning it exists in a false vacuum. That's terrifying, right? I hate to be that guy, but it gets worse. Let's look at what would happen in the hypothetical scenario where the vacuum does in fact decay. If this were to happen, the boundaries that make up the bubble of true vacuum would expand in all directions at the speed of light. This would have insane amounts of energy. So the first and probably least terrifying outcome involves the complete incineration of everything in the universe that is touched by this expanding bubble. Think back to the example of a bubble popping in a pot of boiling water that I used in the intro. In that example, you're here 1 second, gone another. The second involves a complete reshaping of literally everything ever. You see, different vacuum states have different constants of nature. So, by having a bubble of true vacuum that expands and overtakes our false vacuum universe, the basic structures of matter, chemistry, physics, and even life become fundamentally altered. I'm gonna be that guy once again and say it gets even worse. Somehow. In 1980, theoretical physicists Sidney Coleman and Frank DeLucia calculated that if a bubble of true vacuum were to emerge, it would immediately suffer total gravitational collapse. They state,
This is disheartening. The possibility that we are living in a false vacuum has never been a cheering one to contemplate. Vacuum decay is the ultimate ecological catastrophe. In a new vacuum, there are new constants of nature. After vacuum decay, not only is life as we know it impossible, so is chemistry as we know it. However, one could always draw stoic comfort from the possibility that perhaps, in the course of time, the new vacuum would sustain, if not life as we know it, there would exist at least some creatures capable of knowing joy. This possibility has now been eliminated.
That last bit comes from the fact that to truly understand what could and possibly would happen in a bubble of true vacuum, we would need a theory and model that completely describes the multiverse, if there is one. And since we don't have that yet, we can't really be certain of anything. Thankfully, we're probably safe. I mean, from this at least. I can't guarantee your safety when it comes to things like rogue black holes, gamma ray bursts, and other terrifying and apocalyptic phenomena that exist out there in the void of space. I say that because there are current models that predict that metastable universes have a much longer lifespan than the current age of the universe, meaning if this were to happen, it would be future you's problem and not present you. Beyond this, energy output by the Big Bang and subsequent expansion of the universe was originally thought to be enough to push the early universe into a true vacuum state. Remember that high energy event I mentioned earlier in the episode? Pretty much that. The thing is though, we're still here, meaning that this inflation either didn't output enough energy to tip the universe over that edge, that inflation may not have happened at all, or that the universe itself is more stable than we previously thought. So you can sleep easy tonight, knowing that you're more likely to die from a falling vending machine than to simply be Thanos snapped out of existence. But beware, because if this were to happen, there'd be nothing you can do to stop it. Meaning 1 second, you could be at your computer enjoying Baldur's Gate 3 over a cup of pumpkin spice latte, and the next, you and everything and everyone you ever loved, cared about, debated philosophy with, got into fender benders with, did hot sauce tastings with, and even bought peanut butter flavored whiskey for could be wiped from Sleep tight. Thank you so much for tuning in to today's mystery. If there's a mystery you'd like me to cover, don't hesitate to leave a comment on the video or send an email to mattsmysterystories@gmail.com. If you like what you saw and are interested in supporting me on my journey, consider subscribing to the channel. I post once a week and will drop the occasional bonus episode if I have time. It goes without saying, the world is full of mystery, and I hope to share as many of them with you as possible. Until the next one, this is Matt telling you to stay mysterious.